If you're going to program C++ in the Unreal Engine, you should understand blueprints. Blueprints are what designers and artists will create. A blueprint is just like a class. So you can create them by right-clicking Blueprint class, and we'll parent this one off of actor. So we have a Blueprint actor class. So let's take a look at the features in Blueprint that designers can use and how they translate to code. First, check out the class settings. We can set the parent class here. I've created a native CPP actor in code that we will make as the parent class of this actor. Right now in code, this actor is mostly empty. Beside the class settings, we have the class defaults. Here's where you can set the default values for variables in the actor. This is similar to the C++ constructor. And in C++, if you want to set defaults, you would do that in the constructor. So for example, replicate movement. If we go over to the code class, and we write a constructor, and in the constructor we'll say set replicated movement to true. We have to use the setter function because this is a private variable. If we save that in live code, we can search for the property in movement, and because we had it off by default, it now says that we are no longer at the default value. We can revert to the default value, which is what we set in the constructor. Next, we have the components view. There are two primary types of components in Unreal. There's sync components and their derived classes. Then there's also actor components. The blackboard component is used for AI. It is just an actor component, and it has no spatial awareness. So if I add a cube component, we can move the cube around in the scene hierarchy, but we cannot put the cube under the actor component. So there are two files. There's the actor component, which is more for like data components. And then there's the scene component, which is for representing things in a scene hierarchy. You'll see that most things derive from scene component. The more common scene component is actually a primitive component, which is just a scene component. A primitive component has some sort of geometry associated with it, where a scene component just might be a hierarchical helper. And as you saw, you can add more components by clicking the add and naming your component. You can access the component details by clicking on it and changing the properties here. There's also the event graph, which are kind of like functions, but they're all done in one large graph. So begin play is an event that happens when an actor comes into play. We can test that by printing begin play. Another nice feature of the event graph is that you can use latent nodes like delay. So this delay, you can delay for some amount of time and then print after the delay. If we take our blueprint actor to the side and over here, so if we pull our actor into the world and play, so we saw begin play and then delay over. The event graph is useful because you can easily debug stuff visually. In the filter, we can set the blueprint selected, and if we pi, you can see the red. You can see the execution wires are highlighted red when they execute. Let's increase the delay to say 3 seconds. You can see begin play got up to the delay, and then the delay happened. Blueprint can create its own custom events. And can call them whenever they want. So after our delay, we'll say PP custom event. And at a high level, that is how custom events work in Blueprint. In code, we can create events that will execute in Blueprint. If we go over to our actor, from code's perspective, events are just functions. And so we have to use the special UFunction macro to specify an event. In the parenthesis of the UFunction, we can say blueprint implementable event, and then type void, and we give it a name like on blueprint implementable event called. Now the thing about blueprint implementable events is that in code you do not give them a body. You invoke them in code and the blueprint will do some response to that event. So let's have something to call that event. We don't want to do it in the constructor because that is for setting up default values. Rather, let's do it on something like begin play. So we can hit Alt-Shift-Q in Visual Assist, implement virtual methods, begin play. So now we have our begin play method. We will call that on blueprint implementable event called. So in our begin play, we will call that function, which corresponds to that blueprint implementable event, and the blueprint can do stuff in response to this. Now say you want an event in C++ that also can execute code in C++. You can create an event that has native code by doing ufunction blueprint native event, and blueprint can still override this, but you can have a default implementation. So we will say void on blueprint native event called. And if we try to generate a body of that function through Visual Assist, create implementation, you will see that we get an underscore implementation. So the underrow header tool is going to generate some code that will map this event call to invoke this implementation. And this will not be called if the blueprint overrides it and doesn't call the parent. So to test this, we'll just create some code to debug. So static x is 5. We'll drop our breakpoint here. We have to save our header. So with both files saved, we can hit Control Alt F11 on Windows to attempt to live compile. See, we have some compile errors. Until I fix my compile error, we'll try to compile that again. So now that we're in Blueprint, we can right click to access our event. We had the Blueprint implementable event. And I'll just print to make sure that's happening. And now I'll only implement this event for now. If we compile that and run, you can see that the execution has been highlighted and we printed the message. So if we go to our code and we call our blueprint native event, we called our own blueprint native event and we've compiled that into the executable, we can see that we are executing the event's code. And if we take a peek at the call stack, you can see that it wasn't directly calling the event. There was some generated code before it called our implementation. The main use of this is to provide a default implementation, but let Blueprint override it. So Blueprint lets override our native event. I'll copy the message, and I'll print native event, and we will see that our breakpoint will no longer be hit. So put a breakpoint in our implementation, run the game, and you saw that we called this event and it printed, but we never hit our breakpoint. Now say you actually wanted to execute this code in addition to Blueprint code, what you can do is stop pi, right click on the event, and add call to parent function. This is like calling your super method. And so to make sure we see both calls, let's drop a breakpoint on our Blueprint print and run. So you can see we hit our default implementation. I'm going to remove this breakpoint and I run. And now we've hit our Blueprint breakpoint. Also note, you can debug blueprints just like you can native code. In the Blueprint window, we have these step functions. They have the same bindings as Visual Studio, to step over, step into, step out. And you can resume execution here. Note that under Tools, Debug, Blueprint Debugger, you can get more information like a call stack and some other data. I'm going to remove the breakpoint with F9 and resume. Under the event graph, there's a section for functions. And by default, there is a special function called the construction script. The construction script is a bit different than a normal function. The construction script is a bit harder to debug, and it executes at special times. It is called when you place an actor into the level, and it is called when you spawn an actor dynamically. But actors in the level, when you start the level, will not have their construction script ran again, because they've already been constructed. Now, based on the name, you might think this is the constructor in C++, but it is not. The constructor is for setting up default values. The construction script has a different purpose. The construction script is primarily for setting up stuff in the world. For example, if you needed to lay a wire between 2 points, you could do that in the construction script and do line traces to figure out where to lay the wire over geometry. In code, we can do something similar to the construction script by implementing a virtual called OnConstruction. Note there might be some subtle differences here, but it serves a very similar purpose. I've heard that if you override the construction script, you might be interested in overriding post, edit, move. I believe moving an actor used to only call this one, but now by default, post, edit, move seems to call it OnConstruction also. The benefit of doing this in code is that you can easily debug these, whereas debugging the construction script in Blueprint is kind of finicky. In code, we can just drop breakpoints and it'll work. So if we were to move an actor that had a wire in the level, we'd need to refigure out where the wire goes. So we rerun the construction script. So if we attempt to move the actor, we should see our breakpoints trip. So we have a breakpoint in the post-edit move, and then it also calls the OnConstruction. So if we were doing line traces here to figure out where to lay a wire, after we move, we could rerun those traces and update our wire. More generally, Blueprint can create functions. Functions can have return types. You specify the inputs and outputs of functions via these inputs and output nodes when you click one of those function nodes. So we can add an input, we can add an output, and then in our event graph we can call our function. Note that there are two types of functions. There's the regular function like this, but we can make pure functions. A pure function does not have an execution pin going into it. So if we mark it pure, you can see that it's just a standalone node, and we can plug it into parameters to other functions. Note that BlueprintPure functions are executed every time they're used. So you might look at this and think this only executes once and then uses the same parameter in both, but I believe this actually will execute 2 times, one for each call of this function. In code, it is pretty easy to set up a function for Blueprint to call. All you need to do is write UFunction and say that it is Blueprint callable. And then give it a name, give it some implementation. Now this will be a regular Blueprint function that requires execution pins. You can do a similar thing by adding BlueprintPure onto your function. So to make this clear that this is coming from code, I'm going to name it native. So in Visual Sys, I'll shift Q, rename. And now if we live code this, well, we need a body first. So we live code this. In Blueprint we can call. There's our native callable getFloat. And then there's our native BlueprintPure, which we could plug into some function taking a float. And that, at a high level, is how you expose functions to Blueprint. Underneath the functions section, there's a macro section. Macros are mostly a Blueprint-specific thing. Macros take execution pins. So if we go to exec, you can have multiple execution pins going output. So say option 1 and option 2. One primary difference between functions and macros is that macros can have delay nodes in them, or other latent nodes. If you try to add a delay node to a Blueprint function, it is not available. Functions can also theoretically be called by objects outside. I'm not sure that's true for macros. So in this macro, we'll delay 3 seconds. And we could do some logic here to determine our outputs. If we go to the event graph, in our custom function, we will say, use our new macro, which I did not name. And if option A goes, we will print option A. Option B. Now if we compile that and debug it, we should see that because of the delay, the macro will execute sometime after reaching these nodes. There. So macros let you have latent nodes internally. Here's a full list of the differences between functions and macros from the Unreal Engine documentation. Macros are copy-pasted at compile time into the graph. Macros let you do latent nodes. They can use any node for the class they're scoped to. But functions let you override functionality and chop blueprints. Since macros are mostly a blueprint thing, we can move on to the variables section. In Blueprint, you can add variables under the variable section. So we've added a bool. You can drag the variable onto the event graph and choose either get it or choose set it. You can hold Control for a quick get and hold Alt for a quick set. If you compile, you can then set the defaults by going over here and setting the default value. You can also access the defaults via the class defaults and type in the name. When arriving at blueprints you did not set up, you may look at the class defaults and see a lot of data and not know what was changed for this blueprint. One quick trick is to click the little cog here and say show only modified properties, and this will allow you to see what has changed from the defaults of the class. So if I change the default from replicate movement to be false, which we have set to true in code, and I tell it to show me only modified properties, I can see that this default has been changed. And then I can revert it with this little arrow. So if you remove the modified properties filter, there are other properties for this variable that you can set up by clicking on the name of the variable. For example, you can set the replication to be replicated from the server to the client. You can set it to rep notify so that when it replicates, there's a function that gets called. So how do we set up variables in code? To keep this simple, I'll just make the variable global for demonstration purposes. Variables are called properties, so we'll type UPROPERTY. A raw UPROPERTY like this doesn't expose it to Blueprint, but it does protect variables from garbage collection. It does protect variables from garbage collection, but we want to actually expose this to Blueprint, so we will say edit anywhere. This is the most relaxed requirement. This lets you edit the variable on the defaults of the class. It also lets you edit the variable on the instances of the class in the level. And if we want to be able to write script with it, we'll say blueprint read write. So not only can they edit the defaults, but they'll be able to connect it in their script and change values there. And so we'll make this a float, and we'll call it, well, my CPP float variable. If we try to live code this, we can now right click, get my CPP float variable, and we can right click and say set my CPP float variable. So now this variable has been exposed to Blueprint. If we wanted to create a replicated variable, there's a bit more work you have to do in code. I'll speak more to replicating a variable in code in a later video, as it's a bit out of the scope of this video. But just in case you're curious, for example, if we open up a scene component, we can see relative rotation. You can see that it is replicated using onRepTransform. This is a function that gets called when it is replicated. So if we search for that, you see that it must be a U function, onRepTransform. And one other thing you must do is you must override a virtual method called getLifetimeReplicatedProps. So there's an old way of replicating things, which worked by constantly checking and if a value changed and replicating it. And then the new way, which is the push replication, which means you have to mark a variable dirty before it replicates. So with push, we create this do replication lifetime params, set it to pushed, and we can see that the relative location is over here as being flagged as something to replicate in this virtual. And if we look at where that's set, there should be a macro to dirty that. And we can see in the function that sets the relative location, they call this mark property dirty from name, scene components class, relative location. This marks it dirty and tells the server that it needs to replicate it to the client. So that's how variable replication works at a very quick high level. That'll be discussed in further detail in a later video. The last feature to look at are event dispatchers. Event dispatchers are what they kind of sound like. They're a way to create an event that other blueprints can bind to. So if we make an event dispatcher, we could broadcast this and have another blueprint subscribe to it, and then it would get notified of the event. But to keep things simple, we'll just do it all internally. So on our event begin play, let's subscribe to this event dispatcher. So we'll add a call to bind, just like subscribing. So we'll bind to our event dispatcher. So that we don't get hit by a delay, actually I'm going to pull this before the delay. We'll create an event to handle it. And here we could connect it directly to the event, or we can do create event. And after we compile, set it to the handle and dispatcher. And here we will print. And then after our delay, what we'll do is we will call our event dispatcher, dragging over here and do call. And that will ultimately, since we subscribe to it, it will call this function. Now, the sequence should go to the next pin once we hit the delay, but just for clarity, I'll move it here, move this first so that it looks like we bind it first. So we bind it, delay, and then call it. So I frame this so that we can see it, move it to the side. So we hit our delay, and now we're going to broadcast. So we broadcast, and you saw that we executed the event dispatcher. So if we want to create a general event dispatcher in code, we can do that. In code, they are called dynamic delegates. Code has many types of delegates. There's multicast delegates, return valid delegates, events, and dynamic delegates. Dynamic delegates are what most closely correspond to the blueprint's event dispatchers. So the way they work, we declare a type. So we'll say declare dynamic multicast delegate. We'll give it the type name, so f on delegate. After we give it a type, we create a variable of that type. Now, in order for Blueprint to bind to this, we need to make it a UPROPERTY and make it Blueprint assignable. Without this, code could still bind to it, but in order for Blueprint to bind to it, we have to expose it to Blueprint with this Blueprint assignable. Now, code can also bind to these. So as an example, let's create a handler for it. So because it's a dynamic delegate and not a regular multicast delegate, we must make it a UFunction. So with multicast delegates, it doesn't have to be a UFunction. With dynamic delegates, it must be a UFunction. So we'll have a UFunction, and we'll say void handle our dynamic delegate. We'll create a body for that. I'll throw some temporary code in there. But then we have to subscribe our handler. So what we'll do is we'll subscribe on begin play and unsubscribe on end play. So we'll go to the class, implement virtual methods to end play. And so in our begin play, we'll say on native event dispatcher, add dynamic, and we can entry and search that for some examples. But we just need to pass it the object that's binding, which is this object, and then a function pointer to our handler. So that'll be this class. And then the function name is handle our dynamic delegate. Be sure to do the ampersand since this is a function pointer. And we'll copy that, and then in play, we will paste it. And instead of add dynamic, we'll do remove dynamic. And so this binds our event dispatcher. And this unbinds our event. But we still need to call the event dispatcher. So what we could do is create a function real quick to do that. So UFunction implement callable. Make that function, and we'll say on native event dispatcher.broadcast. Okay, so now we've set up to handle it. If we compile this, see if we have any errors. Be sure to put a semicolon after declaring your type. And I've put a breakpoint in this function so that we can debug it and see that it's working. So what we need to do is bind to our event dispatcher. So there's this special helper called assign on native event dispatcher, which will bind it to an event and create us an event for that binding. So I will print this. Handle native event dispatcher. So now Blueprint should also handle it. And where we were calling our other event dispatcher, I will just call our function we made, call native event dispatcher. So this is the function we wrote. If I double click, it takes us to the function, and all it does is broadcast. Alright, so now that that is set up, we should be able to see this happen. So I will drop a breakpoint here, and we will play npy. So we hit our breakpoint in Blueprint, and you can see the execution pins that caused this to happen. So I'm going to resume. And you can see that we also hit our handler in code. So with event dispatchers, you probably do not want to be relying on the order of the handlers being called. And so that is how event dispatchers work in Blueprint and in code. So these are just the basics of mapping Blueprint features to code features, and we'll explore most of these in greater detail in later videos, but this should get you started on being able to write code in Blueprints. Until next time.